Section 6.2, determine the value of k in A12 and B negative 4k given each slope. So you're given 1 point already, 1 and 2. Let's plot that. So 1 on the x, 2 on the y. So the point is right here. That's point A. Okay. And then with a slope of 4 over 5, that means we're going to go, my rise is 4, my run is 5. So from point 8, I'm going to go up 4, 1, 2, 3, 4, and then over 5, 1, 2, 3, 4, 5, and I get to this point right here, which is 6 and 2, 4, 6 and 6. Okay. This is what we did last class to figure out the next point, but I don't want this point. I want the other point, which is on the other side of A. So, just like what we suggested last time, if you can't go up and to the right, then that means you can go down and to the left because it also falls on the same line. So going down for 1, 2, 3, 4, and then 5 to the right. 1, 2, 3, 4, 5. And there we go. There's point B, which has the coordinates -4, -2. Okay? And so my k value in this case is -2. Okay. Okay. Part B, same idea. So I'm going to plot my A first. My point A is right here at 1 and 2. And from this point, I have a slope of 2. Okay. So this is the same as 2 over 1. So that means my rise is 2 and my run is going to be 1. So up 2 over 1. Up 2 over 1. Okay. My line is in this direction. Okay. But I don't want this point. I don't want this point. I want the point that has an x value of -4. And so I can go the other way. Down 2 to the left 1. Down 2 to the left 1. Down 2 to the left 1. And then down 2 to the left 1. Okay. Remember, all your points should create a straight line because the slope for the whole line is the same. Okay, and so this point right here, 1, 2, 3. Oh, actually, I have to do one more. Okay, my point B is actually right here. -4, and what is that? 1, 2, 3, 4, 5, 6, 7, 8. -8. Okay, because this right here, 1, 2, 3, 4. -4 is right here. And that, if I extend this will be the -8. Okay, how do I know this is the point I want? Because you're given part of the coordinate right here. So that's how I know it's this one. Okay, what if the slope is 0? Okay, so 1 and 2, this is my point A. Okay, last class we talked about when m equals 0, it means it's a horizontal line. Horizontal line. So I'm gonna get a line that goes this way. Okay. So if that's the case, and I know that point B is on this line with an x value of -4, then that means B would have to be over here. Okay? And the coordinate of that point is -4, -4 and +2. Right? This point right here, -4, +2. Okay? And what about this one for D? So I have point A right here, which is at 1 and 2. An undefined slope means that it has to be a vertical line. Whenever it's an undefined slope, it's a vertical line. Okay, so if it has to go through point A, that means my vertical line is over here. Okay, so 1, 2, 3, 4. So when will it cross -4 for my x? It will never. So therefore, there's no solution. Okay, you cannot have a coordinate with -4 and something and pass through this point with a vertical slope, with an undefined slope. Okay. So that's example 1 right there. Okay. Now let's try this word problem. Sarah is on the soccer team and runs every morning before school. One day she ran 5 kilometers in 20 minutes. Calculate the rate of change of Sarah's distance from her starting point. Okay, so whenever you do a graph, because we're talking about speed, we're doing an L graph because you can't have negative speed. You can't have negative time. So this side is the distance and this side is the time. Okay, distance, I can do 0, 5, 10, 15, 20 kilometers, for example. And then for the time, because it's in minutes, I could do 0, 10, 20, 30, 40, 50 minutes. Okay, so at the beginning, before she starts running, before she starts to time herself, you start at 0, 0. So there's your first point. It doesn't always have to start at 0, but in a distance time graph, most of the time it will start at 0, 0. Okay, she ran 5 kilometers in 20 minutes. So 5 kilometers, 20 minutes. Okay, I have this point. Okay, so when you graph it, looks something like this. So looking at this, I can tell what is my rise and what is my run. So my rise, okay, is 5, and my run going across this way is 20. Okay, so my slope is 5 over 20, or I can write it as, when I divide it, 5 divided by 20, I get 0.25. Okay, notice the question asks for the rate of change. Okay, rate of change. What's the difference between slope and rate of change? Rate of change has units. Okay, so here I have my slope to make it a rate of change is 0.25 kilometers per minute, just like unit rates. Okay. Graphs Sarah's distance as it relates to time. So we have this. Explain the meaning of the rate of change and how it relates to the graph. So in this case, her rate of change is her speed in distance time graph. You'll do a lot of distance time graphs in this course. And when you do a distance time graph, this line right here, the slope, it represents the speed. Okay, and so if she has a consistent speed throughout, it should take her 40 minutes to finish 10 kilometers. Okay. Okay, and then the final example right here, fuel consumption. The graph shows the volume of gasoline remaining in the car's tank. Calculate the slope of this graph. So I have my first point right here and another point right here. This point is 0 and 65. This point is 505. Okay, comma 5. So to calculate the slope, I want to do rise over run. Okay. Okay, so for the rise over run, my rise is not 65. Even though this says 0 and 65, my rise is actually only 60 because this point is only up to the 5, right? So you're actually looking for the difference between 65 and the 5, and so your rise is 60. But notice the direction of the line. The direction of the line is this way, dropping to the right. So my rise is negative 60. I'm going down 60. And then my run, which is from 0 to 500 across. So my run is 500. Okay. When you divide this out, negative 60 divided by 500, you get negative 0.12. Okay. For here, that's your slope, negative 0.12. Interpret it as a rate of change. So remember, in a rate of change, you have units. So what's my unit here? You take a look at your axis. Liters, kilometers. So liters per kilometer. If I were to interpret this in a sentence, then therefore, the gas consumption consumption the gas consumption of this car is it minus 0.12 liter per kilometer, or you can say it uses 0.12 liters for every kilometer it goes. Okay, so that's the lesson, and the homework is going to be on page 2. Sorry, not page 2. Page 4. Okay, page 4. Starting from number 1. Okay, So number 1 to 14. So page 4, 5, number 1 to 14, and the challenge questions will be number 15 to 16. Okay, thank you.